But let's start with number 1. So as the tile falls from the roof of a building to the ground, its momentum is conserved. True or false? People at home? You said true. Okay. We got 1 vote for true. Table 2. True. Table 3. True. Table 4. Right here. Front.
True.
True. Table 5.
True.
Everybody wants to be the same. Okay. Let's see what the people at home said as they quickly change their answers. Okay. Most of them said false. A few were confused and stuck on C, D, or E, but that's okay. So most people said false if they were answering question 1. Hopefully they were answering question 1. Let's talk about this problem for a second. Okay. We've got a building. It's up here at height H. We have a tile that's going to fall off the building. When it first dislodges from the building and starts to fall, what is its initial velocity? A nanosecond after it falls off the building, what's its speed? 0, right? It starts from rest, just like dropping a rock or anything. Okay, and then the object's going to fall, and it's going to hit the ground. Right before it hits the ground, what is its final speed? If it's height h, what's its final speed? And you should be able to answer that in about 2 seconds. (2gh square root). It's not so bad, right? How do you get that? Well, mgh equals 1/2 mv squared. Potential energy goes to kinetic energy. You cross out the m's. You multiply across by 2. You take the square root. You get v. Okay? That's the final speed. All right. If that's the initial speed and the final speed, what is the initial momentum? Well, it's mass times velocity. So it's what? What is it 95% of the time when I ask you? 0. Okay. P final is mass times velocity, which is mass times square root of 2gh, which is decidedly not 0. So when we say momentum is conserved for the tile, you have to ask the question, does Pi equal Pf? Does Pi equal Pf? 0 equals that? No. So the answer is no, which is false, which is answer B. And 0 of you here got that one. Okay? So this is good that we're discussing it, right? We're here to learn. So wait a minute. That's a little confusing though, right? Because we said that we have conservation of momentum, right? That's one of our founding principles, conservation of momentum. But there's a little bit of a caveat with that. What is the caveat? What goes in the parentheses here? When did we have conservation of momentum? In this case, we clearly did not have conservation of momentum. Why? What was causing this thing to fall and get faster as it went down? Gravity. Exactly right. Conservation of momentum only works when there are no external forces present. Namely, if you draw a dashed box around your particular system of interest, are there forces that are crossing that dashed line? Yes, gravity is crossing that dashed line. And so that is not the system that is conserving momentum. What is the system here that's conserving momentum? If it's not the tile itself, what do we also have to include in the system? The earth. The tile earth system does conserve momentum. So you have to be very careful about what you mean by the system. If we're just saying the tile itself, that's not enough. We have to include the earth as well.